you. I'm going to share screen.
Do you know how to reach your hand?
And what do you think you see on the screen?
The ones we made?
Yep. So what's really cool about this is that these first two were made by a couple of mathematician partners. So Hannah and Frankie love to do mathematics together. And what they do is they work together and then they send me their work and I get to see the fruits of their labor, which is really, really cool. So I enjoyed they made their own version of Monster, I guess from Monsters Inc. Mike. But look at the one on the right.
Toast.
What do you think that is?
Toast.
French toast.
It is toast. And they made two, I guess each of them made one. And they also called it a dodecahedron. Now, I have never thought of toast as a dodecahedron, but you know that I am never going to be able to eat toast the same way. So guess what I did when I saw this? The next time that I had toast, I took my knife and I literally cut an exact dodecahedron model of my bread just because of Frankie and Hannah. So that was kind of a lot of fun for me. Now, they made another one, and then Raymond, a kindergartner, makes an owl. I wanted you to see that. Alice is another kindergartner. Not only did she make this really cool monster, but she also gave me the coordinates. This is a kindergartner doing -4, -7. So I was really amazed to see the wonderful work that she could do. Then I got to see Julian's Bart Simpson, Allison's eagle, Kennedy's eagle, his Diplodocus, and now Ava, I gotta tell you about Ava. Oh my God. Ava got this Easter egg. She found these coordinates. I did not give this to her. They have halves. I don't think they have any quarters, and they're only in the first quadrant. But it really is quite a beautiful picture. And then I think there was a few more. We had Hayden Schmidt did a sailboat, and she colored it in. And I just wanted to share that because I was really, really excited. Can you guys hold up any of the work that you created this week? I would love to see any of the work that you've created. And if you feel comfortable showing it, then I would certainly appreciate that. Okay, so you can continue to find it if you want to.
Hey, which one?
Well, I want to see whatever you created, something you're most proud of.
Last
What are you
week?
most proud of?
Last
Show me,
week?
Cole. Yeah, go ahead, Cole, show me.
I can't find the packet.
Oh, okay. So maybe you'll send it. You'll have your parents send it to me, and I'll put it up on the website. Okay.
You have to want the packet for where the one like 3 weeks ago or 2 weeks ago.
Well, I'm talking about the packet from last week where I sent your parents a packet, and I said, do not print it because it was so long. So it was really there for you to choose any picture you want. And then, oh my God, read. Let me see that again.
Let me turn off Miller so you can see what it actually looks like.
Okay. Oh, wow. That is beautiful.
No, it's not.
Oh, come on, Lisa Simpson. I don't know. I'm a big fan. Okay.
Thanks, I guess.
I'm going to open up questions now. Do you remember that we talked about Sir Isaac Newton last week?
Yes.
And you remember that we said that Sir Isaac Newton, he didn't just come up with calculus and the laws of gravity, but he also came up with the laws for optics. And part of the work you do with optics is with magnification. So can you tell me why an eye doctor would want your pupil to go from this diameter to this diameter here? What do you think is the reasoning for the eye doctor to go to a different size of your pupil? Brody, why don't you take it first?
It's easier to see, I guess.
When you say it is
the
easier
pupil?
to see, what is the it?
The pupil?
Yeah, but why do you think the doctor's interested in the pupil? Like, why would it be interesting to see this black circle? And Reed, why don't you help out here? Because I think this is I think that Brody started us off on a really interesting discussion. Go for it.
All right, so when you do it, one of them, when your eyes are bigger, or smaller, I forget, the darker it is, the bigger your eyes get, or I forget if it's smaller, and the lighter it is, the bigger it gets. Because
Well,
different level of light is the different diameter of your eye size.
well, I'm going to set you straight on that in just a minute, but I want to hear from Bogdan first. Go for it.
They want to see if your eyes like react to the light, I guess, because if it's darker, they want to see more, so they expand, and if it's lighter, then they shrink.
Everybody, take a little journey with me here, okay? If right now I turned on a big bright light, do you think my pupil would want to be bigger to let more light in? Or does my pupil want to protect my retina, my optic nerve, and my blood vessels? What do you think my eye would do? What do you think, Rennie?
I think they would want to make it smaller so that less light would get in.
If there is if you look into the sun, which you should never do, but by the way, I'm doing it right now, sort of. I'm looking out my window at the sun. My pupils right now got really, really tiny because my brain says, oh no, too much light, close that pupil. So Reed, when it gets dark out, your eye opens up and says, give me light. Does that make sense?
Yeah.
Okay, so guess what? When a doctor examines your eye with the light, remember he puts the light or she puts the light right in your eye, normally your pupil will get very what?
Small.
So what the doctor does is she artificially dilates your eye large so she can look magnification in the same technology that was created by Sir Isaac Newton and see what's in the back of your retina and optic nerve. Pretty amazing stuff. Now, who can tell me the scale factor going from the small pupil to the large pupil? It's a linear scale factor. And I want you to send me a chat. And the only thing I'm going to do for the hint is to throw this radius right near the larger one. And you want to tell me the scale factor. All right. So I'm looking for a chat here. And oh, interesting. But remember, the scale factor, if it gets larger, is going to be a number greater than 1. So let's say you think it's 100 times bigger. You would say it's a scale factor of 100. Okay, now obviously it's not 100, but that's what I want to start you off with. So Evan, I like what you're saying. Reed says a scale factor of 2. Brody, I'm going to go with yours. Brody, tell me why you thought it was a scale factor of 3.
Because 3 of the smaller pupil diameter makes up the larger one. So.
Yeah, I'm even going to clone this right now. And I'm going to clone it again. And if you notice what I'm doing is I'm putting them kind of side by side. And so it's not exactly a third, but it's pretty close. So I would say that this is a scale factor of 3. Now, who can tell me the scale factor going the other direction? And so don't say it out loud. I'm going from the bigger to the smaller, which is also a dilation. And I want to hear from you. And remember, this is going to have to be a fraction between 0 and 1. So on 3, 1, 2, 3, go.
1/3.
Third.
1/3.
And guess what? This would be a dilation that reduces. So a dilation, a scale factor that's between 0 and 1 gets smaller. Who can tell me what happens with an enlargement? A
It gets
dilation that enlarges. Flag in, please. Evan, why don't you tell me? What's the scale factor going to be for an enlargement?
It's gonna be not reduced. It's gonna be multiplied.
So, well, no, we're multiplying by 1/3 to go from here to here. But what I'm asking you is, what is the scale factor if we are enlarging, like from here to here? It has to be greater than what?
1.
1.
Yep. So it
1.01.
has to be greater than 1. Anything bigger than 1 will reduce.
Right.
So let me ask you this. And Reed, you have a question, buddy. But Reed, yeah, go for
It won't be either of those if it's 1, so it has to be more than 1. It won't reduce or
So what is the scale factor of 1?
it's fine.
Milo, if I took
Same.
you, Milo, and I made a scale factor of 1 out of you,
It'd be the
would
same.
you get, wait, Reed, Milo, what would you get? Would you get bigger or smaller?
Bigger.
So you think a scale factor of 1 would get bigger. Remember, an enlarged scale factor gets me
Oh,
to enlarge.
smaller.
A reduction is less than 1. So what would a scale factor of 1 be, Milo? What do you think?
Smaller.
Smaller would be less than 1. Bigger is greater than 1. Bogdan, what do you think?
It would be the same size.
Yeah, guys, right now, look at yourselves in the mirror or look at yourselves in the screen. You are a scale factor of 1. You are you. And I'm going to show you a scale factor of 1 right now. This knight right here is a scale factor of 1. He's my original chess piece. Now, what do you think the scale factor is for this one here? Don't say it out loud. Don't say it out loud. Chat to me this scale factor. So a scale factor is going to be what? On 3, 1, 2, 3, go.
2.
I totally agree. Very nice. A lot of people look at this and they say something else. And I'm going to tell you in a second. Oh, hi, Ben. You're rejoining us. Awesome. Fantastic. Now, who can tell me the scale factor of this guy right here? Ben, you want to take that? Can you hear us? We can't see you, but I'm hoping we can hear you, Ben. What's the scale factor of this guy right here?
1/2.
Oh man, you totally nailed that. You totally nailed that. Fantastic. So this guy is a scale factor of 1/2. He's a scale factor of 1. And now I want to ask you a bonus question. What would happen is if I had a scale factor of 0?
Oh, nothing.
What would happen? Please send me a text or a chat, I should say, or a raised hand. and I want to hear a scale factor of 0. What happens? Cole, do you have any ideas on that one?
That. Well, you. No.
Okay, Bogdan, help me out.
I think it would be nothing.
What do you mean nothing?
It would be like you can't even see it that small.
Guys, what's happening? What's happening?
It's
Getting
shrinking.
smaller.
A scale factor of 0.
Oh, that's a scale factor of 2.
Actually, it was, but now it's a scale factor of 0. It disappeared. So you cannot have a scale factor of 0 unless you literally want it to disappear. Scale factor of 1 is 100%. Do you know that I once, one summer, you got to hear about this. I had a map of the United States, and the scale factor was 1 mile equals 1 mile. And a couple of summers ago, I folded it. So it was a very large, do you think that would have been a very large map?
Yes.
Oh,
Yeah. How about 3,000 miles by 1,500 miles? Okay. So you really could never have a scale factor of 1 on a map. So let's move on. And I want you guys right now to go to page 4.
I have no pages.
Say again, please.
I just said I don't have no pages.
Okay, you don't have any pages, and that's fine. If you get to learn, to print from your house, then you'll be able to see this. Otherwise, you could just see it online, maybe on a different tablet. If you got a different tablet, you could have that open
It's
in
fine.
that tablet. So I want you guys to tell me, what is the scale factor right now? And Ben, you can weigh in on this because I haven't heard from you yet. The scale factor from A to C. So send me a chat, scale factor from A to C. I am looking for, and you can look at the points on each of them. So we're looking to go from A enlarged to C. And I haven't heard from, oh, interesting, Milo. And Milo, look at the actual coordinate numbers. Brody, you got it. Reed, you're kind of close, but you're guessing. So I want you to use a little multiplication here. Now, Cole, very interesting. Cole's answer is not wrong, but it's not the scale factor. So Cole, I'm not going to say your answer yet to anybody. I'm going to have you explain to me what you meant, but let's first talk about scale factor. Everyone, did we go from 0.23 to 0.812?
Yep. Yes.
And so Evan, what was the multiplier? From 2 to
4.
8 was what?
4.
From 3 to 12 was what?
4.
4. From 5 to 20 is what, everybody?
4.
4.
From 1 to 4 is what?
4.
Exactly. So we know that the scale factor from A to C must be exactly 4. Make sense? Now, I'm most interested in Cole's answer. Cole, you said 16. What did you mean when you said 16?
Like, because, like, 4 of the littlest ones could fit into, 16 of the littlest ones could fit into the biggest.
So you were not talking about scale factor. So Cole was actually talking about, anybody want to take a guess? Go ahead, Bogdan.
Area.
And Brenny, what were you going to say?
I was gonna say area too.
Well, check this out, guys. On your next page, I want you to see what I did. I literally was thinking about what Cole said, and I would say, how many A's could fit into B? Answer?
4.
4.
So we know that it has a scale factor of 2, but an area factor of
4.
4. But what about this guy? From A to C, Cole, explain.
16.
Why?
Because if four of the B's could, if 4 of the A's could fit into the B's, then 4 B's could fit into the C.
That's right. And guys, do you see the 16 right here?
Yep.
Isn't that cool? Now, I'm really, really interested to ask you this question right here, but you're going to have to look very closely. I'm going to make it even bigger right now. And I'm going to make a little triangle that's green. And I want to ask you, don't say it out loud, how many of this dilation, and by the way, this green triangle is a dilation of 1/2 of A. He is 1/2 of A. He from the green, we would go to a dilation of what to C? From the green, what would be the dilation? Remember, scale factor is linear. What's the dilation? On 3, 1, 2, 3.
32.
32. Oh, 32.
I do not agree with 32. Come on.
2 and A. That means there's 8 and B.
64.
2,
8 and B.
3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Guys, from little to big is a scale factor of 1 to 8. So it's a scale factor of 8. Now, one of you already said it. What is the area factor? Don't say it out loud. From the green to C, what do you think? On 3, 1, 2, 3.
32.
32.
No.
I didn't do
I
the
do
math.
not
for that.
agree.
64.
64.
Uh-huh. Everybody look, when you square 8, what do you get?
64.
So if you square, and isn't area in square units, guys?
Yes.
Yeah.
So that's why we can do 1, 2, 3, 4 in each of the 16. 16 times 4 is, and Ben, give you a thumbs up there. Thank you, Ben. Now, I want you guys to go right now to page 6. Go to page 6 and you will see a little chess piece. Now, what I want you to do, this is your job, is I want you guys, and not everybody's going to work at the same pace. I want you to dilate this to a scale factor first of 2 and then 1/2. Now I want to show you what to do. Everybody start with 0.24. Do you see 0.24?
Yep.
Now dilate that point to a factor of 2. On 3, 1, 2, 3.
4, 8.
4, 8.
And there it is. Dilate this to a factor of 1/2. 1, 2, 3, go.
1, 1, 2.
And there it is. Oh, and by the way, those 3 points are collinear. They are collinear and will point right to the origin at 0. So I want everybody right now to start. And as you're doing this, if you have any questions, please ask me. So, and raise your hand electronically, and then I will see your question. So Reed, get started. Go for it.
I don't have the paper to do it because I couldn't print it out.
I understand that. Now I can't help you with that piece of it, but what I can do is offer that you take a piece of paper and you sketch out a graph And you could really do make like a very easy sketch of the night and then try to dilate it to a factor of 2. So you have a harder job than anybody else, but it's a good job.
Alright.
I'd want that job.
Where's the tiny pencil? Oh, it's right there. I got it.
All right, good man. Because people that do what you're doing right now are very resourceful. Very resourceful. They deal with what they have, not with what they don't. Bogdan, go for it.
If you do half of 1, do you go to the half?
You absolutely do, my friend.
Okay.
So you've already done the scale factor of 2?
Oh wait, no, not yet.
Yeah, do that one first, please,
Okay.
and then move on, because it's really much easier to do an enlargement. And certain scientists work in something called nanotechnology, and they create models that are bigger, and then they have to go smaller with the actual. So it's really, really interesting. And if anybody has a question, this will be a great time to ask it. Great mathematicians ask good questions. And I haven't heard any questions yet, so I suppose you guys are on target.
Ah, shoot.
And there is my scale factor of 2. Now I'm going to attempt the difficult. And to do that, I'm going to make it a little easier for me. I don't think I like that. I don't think I do. When you're finished, I'd love to see your work. Cole, how you doing, buddy?
Oh, good.
Good. How about you, Milo? I don't see you.
Good. I'm doing good.
Oh, good. You're there. Okay, excellent. I just want to make sure you're with us. Ben, I can't see you, but if you give me a thumbs up, I know you're there and doing well. You can also
Okay.
send me a chat, Ben, if you have any questions, if you don't feel comfortable talking. All right? And Brenda, do you have any questions?
No.
You're good? Okay. Hey, Bogdan, how did I do on this point 1-1? Did I get the good half-half?
Yeah,
Okay, cool.
pretty good.
Just making sure.
This isn't.
Wow, this is really hard to do the half.
Wait, I got a question. Does it fit
Yeah.
on a 9x9 grid?
It won't fit on a 9x9, and it won't even fit on a 10x10 read.
Oh,
Because do you see how I had to go off the grid north of 10 on the y-axis?
I think it's 12 that you have
but
to have.
what if you move
Right.
it
Wait, do you hear Evan? So Evan said I had to go to 2, 12, and 0, 12. And Reed, what were you saying, buddy?
Can't you just move the whole thing down a little so it all fits? Like 2 squares?
I suppose you could, but I actually was interested in what students would do when you went off the page. So I was hoping that there was a margin for you a little bit on top. And I'm not sure that there was, but I was hoping. A mathematician could just hope, right?
Mhm.
Whoops.
I finished my scale factor of 2.
Can I see it, please? It's absolutely beautiful. Beautiful dilation. Miles, Milo, let me see, buddy. Oh, man. That's nice. That's nice. And Milo, start, and Bogdan, start on the scale factor of 1/2.
Okay.
Okay, yeah.
So -2, 1 would be -1/2. Wait a minute. No, -2, -1.
I finished.
Oh, man. Oh, wow. Brody, what kind of a pen are you using?
It's a brush pen.
How does it work?
Well, it's like an artist pen.
Ah, it's a
Has like
really, really nice pen.
Yeah.
Now, what we're going to do, guys, is I want everybody to just hit the hold button for a second. Okay? And I want you to look at my dilations. And if you made these dilations even smaller, like you did a 1/4 or a 1/8, it would be really, really challenging. Now, I want everybody right now to go to the K. We're going to dilate this K to a scale factor of 3. Now, I want to ask a question first. Everybody, don't anybody start yet, please. What point am I looking at right here? Who can either chat or just say it out loud? Rennie, what do you think?
-3.
-2.
-3, -3. Wait,
Well,
no, no,
-3, -3 is here.
-3, -2. No,
-3, -2 is here.
-2, -3.
-2, -3, you nailed it. Now, Cole, you raised your hand. Cole, could you tell me when I triple -2 and triple -3, because it's a scale factor of 3, what do you think happens to those negative values, Cole?
Well, I think that they be that that -2 becomes -6 and -3 becomes -9.
Guys, give me a shout out if you agree. Do you guys agree with that?
Yes.
All right, that is amazing. And everybody watch where that point goes. -6, -9. So the corresponding point is way, way out there. And I want you guys to now do it. It's going to be a lot of fun. When you're done with a scale factor of 3, you know that I'm going to ask you for a scale factor of 1/3. That's going to be hard. Now, everybody stop for 1 second, please. And who can tell me this point right here? Ben, can you shout it out?
-3.
Ben, you got that? You can send me a chat if you don't feel comfortable sharing. If you're not muted. Okay, I'm going to ask somebody else. Evan?
When you go where, sorry?
Well, I mean, I got a big red dot here. What is the point at that red dot?
It's -2, -3.
-2, -3 is right here, as you can see. Okay,
2
I'm
negative.
asking about that one right
It's
there.
2 -3.
And that is correct. Now, if we cut this to a scale factor of 1/3, who can help me with that one? Reed, why don't you take this one?
A scale factor of 1/3 of
Yep. What do you do with the 2 and what do you do with the -3?
So it's 1 and 1/3 for the 2. Actually, no, not 1/3. 2/3, and 3 turns into just 1. I mean -1.
Ah, if everybody sees 2/3 and -1, you totally nailed it. Does everybody see that? Cole, do you see that?
Yeah.
Okay, Brody?
Yeah.
Okay, guys, get going. Scale factor of 3 to start, and then a scale factor of 1/3 to follow. And remember, Cole already started us off at our first necessary point at -6, -9. Oh, I don't want to do it in blue. And if anybody has any questions at any time, really good to ask that question.
Wait, can I not draw this and just write down the coordinate points?
Reed, that would be awesome. That's a great idea. Brenny, I can't see you. Can you move that so we can see what you're doing?
Mhm.
Great. Awesome. Thank you. Huh. Don't know if green is going to come out that well. How about purple? Let's try that. All right. So I had to enlarge it when I'm going to do the scale factor of 1/3. So 2/3 to 1. Okay.
Where's my erasing?
That would be -1/3 to 1/3. Huh. That would be 2. How we all doing, guys?
Good.
Bad.
Okay.
I'm
Bad. Who's that?
Me.
Oh, so Reed, tell me what point we're working on right now.
I'm working on -1, 1, which is just -3, 3.
Okay, so when you said bad? Why would that be bad when it's
It
perfect?
just I started late.
Oh, it's not a race, my friend. It's
I
not a
know.
race.
I
Remember,
just
it took Einstein, 2,000 years. It took humans 2,000 years to unleash the power of the universe. So trust me, you've got time. You've got time. Huh. I don't agree with that. 3. Oh, it's 2. So that was a ninth of that, wouldn't it? So that would be negative 1/3. Negative. There we go. Oh, wow. Milo, you totally rock, dude. Milo, can you start working on the 1/3?
Yes.
Okay, and this is where you guys are going to have the most questions. So please ask them early and often. And then you might want to color in I have to get some brush pens like Brody.
Mr. Kramer, I'm done.
probably find
Oh,
brush
whoa. Man, that is, everybody look at Bogdan's. That's really cool.
Wow.
That's really cool. Now, Bogdan, I want you to think about how many of the little Ks could fit into the area of the big K. All right, so that's your job. How many little Ks can fit into the medium K, and how many little Ks can fit into the big K?
Okay.
All right, Evan, what do you think?
I think 81.
Dude, how did you do that?
So with the original K, you're decreasing by 1/3. So if you multiply 1/3, if you do 3 times 3, you would get 9. So then from there, once you have 9, what we did for the other one, the with the triangles, the little green triangles, the little green triangles, what's it called?
Where what was that like a 16?
It was an 8 to the big one, and so then we had to 8 squared is 16. So that's
Eight,
how I
wait,
got
wait,
it. I just did 9
what
squared.
is 8 times 8, Evan?
64. So that's and I remember that from the other one. So I did 9 squared.
Wow. Dude, I think that's amazing. Now, what about from the medium K to the big K? Who else can answer that one? Bogdan?
9.
9. Wow. And does it make sense? Like when you look at it visually, if you split up the squares, do you think that you could fit 9 of those green Ks into one of the purple Ks?
I finished the
Yeah.
points.
Yeah.
Oh my God.
I did
That
the
is awesome.
points for the big
And
one.
Milo, I like your K, but I don't think you cut the coordinates in thirds. You drew a beautiful dilation, but it wasn't using the coordinates. So you'll see that the location, Milo, is a little bit high. And Brenny, do you have yours?
Oh, I see.
Yeah.
Milo, do you see that, buddy?
I got the points.
Oh, wow, Reed, that's gonna be so cool when you get some graph paper, Reed. Awesome.
That's just gonna be the big cave.
All right, are you guys ready though? I want you guys now to move to one of my best drawings. So this one here, and this one's on page 13. I really, really like that one. But the one I have on page 12, and you can just look visually, is this one. It's a really pretty scale factor of 1/2. But this one, what does this figure look like to you?
A dodecahedron.
And Evan, I want you to look up, please. And Milo, I want to be able to see you. Ben, if you want to send any a chat on what you think this is, nobody call it out loud, please. Oh, by the way, it's not a square. What do you think this is called? So send me a chat right now with the name of this polygon. The name of this polygon. Ooh, Reed, you're pretty close.
Why
But
not?
I don't agree. Now guys, Ben's was really cool. He said a like circle. Now, I'm gonna show you a, guys, look at this. This is a hexadeca.
Hexadeca.
Watch this. Wait, no, I think I can create it. No, not quite. But this is a hexadecagon with 16. And nobody has texted me yet that the actual number of sides. So I want you guys, Cole, I want you thinking about it. Bogdan, Brody, Brenny, Milo, Ben, Evan, Reed. I want you thinking about, and there's an algorithm here that is actually really easy, or it can be really hard. Bogdan, go for it.
I counted and it was 24, like in my text.
And
Oh yeah.
do you guys see that there are 6 segments in
Oh, I
each
counted
quartile?
7.
So 6,
I
Reed,
counted 7, then I multiplied it by 4 because there's 4 pieces.
Reed, here's what you did. You double counted, because if you start at the horizontal, you can't include the vertical.
Oh.
Isn't that cool? So it's actually just 6 times 4, and I actually don't know what it's called, but I believe it's called a quadra,
Lateral.
a quadra icosahedron.
Wait, how many sides does it have? 24?
24.
Hey Siri, what's the name of a 24-sided shape? Hold on, let me put these.
Off.
Okay, guys, are you ready? Now, who can tell me the radius of this figure? The radius of a circle, as you know, goes from the center to the outside. What is the approximate? By the way, somebody's making a noise right now. If you would stop doing that, I'd be appreciative. Who can tell me the approximate radius of this circle-like figure that Ben was talking about? Circle-like figure. Brenny, what do you think? Milo, what do you think? What do you think the closest number is, Milo?
I know.
Any ideas?
3,
Cole?
3.
Cole, what do you think the radius is? What do you think the radius is? Brenny, what do you think the radius is?
Like 3.2, maybe?
Well, does that look like 3, guys?
3.14.
I mean, that is about 3 and a little bit.
10?
This is 10.
Exactly.
This is 10. This is 10. And this is 10. What about this?
And
How do you
No.
know?
no,
Because everything else is 10.
no,
Count 10.
Well,
that's
I will
not.
tell you a story. We talked a little bit about this last week. This guy is 8. This guy is 6. The square of 6 is what, everyone?
36,
The
36.
square of 8 is what?
80,
80,
64.
64.
64.
And therefore, the square of the third side would have to equal what?
100.
And if the third side squared equals 100,
It's 10.
what is that
10.
side?
10.
And
It is 10. Now, I just want to show you, this is a little advanced for where you guys are right now, but that guy right there is 91. I think that this is about 100 and Cole, if you could stop spinning that, I'd appreciate it. For some reason, it's making me harder to concentrate. So 81, I'm gonna say that that's around root 97. From here to here, it's slightly shorter than 10. And what do you think this is from here to here, guys?
More than 100. Because
No, if that's root 97, then what do you think this is?
98.
97.
It is also root 97. And this guy here is slightly bigger than 10. So that is going to be the square root of, you ready for this? Anyone know it?
110.
101.
Oh, Bob
103.
got it. It's the square root of 101, just slightly more. So if you guys work this, you can do a dilation of 1/2 and 1/4, and I think you're really gonna love the picture. Now, I want you guys right now to please choose a diagram. What would you like me to draw? Why don't you choose like a letter? Why don't you choose a letter?
Mathletes.
Well, we already did the M. We
B.
already did the
B.
M. This is an M
B.
scaled down
B.
to 1/4.
B.
B.
Oh,
B.
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 Oh, B.
B.
Okay, B is kind of fun. And what I would probably do is I would start with a smallish B and
So it's
maybe
easy to
do a
make
little bit of
bigger?
curving here. And then I might even go like this just to make it a little bit.
that
Different.
looks like an R. If you took away the bomb one and rearranged it, it could be an R.
Yeah, it's not the best B I've ever made. I maybe should have chosen some different scales. But what do you guys think? Pretty good B?
Pretty good.
Yeah.
Now, if
the
you
bomb one should go
expand this, what dilation factor could we do, guys?
3.
What would be a fun scale factor?
3
4.
or 4.
8.
I'm actually dreaming of a scale factor of 4. So, but I would be off the page here. Yes?
Yeah.
How about this
Yeah.
one here? 0, 12 right here.
Yeah. It'll be
And then what about this one? 4, 8. You guys with me?
Yeah.
Yeah.
Scale factor of 4. Scale factor of 4.
Hey,
you
it
guys-
looks like
What do you guys think?
I think it's big.
Yeah.
Just
I
like
think it
B.
might be too big, but I want you guys to be really, really creative, okay? Come up with some really cool pictures and dilate them. And then I want to now go from -20 by 5/2.
Halves.
Are you guys ready? -20 and
Right.
5/2, remember, is exactly what?
10.
2 and a half. Okay, let's go. Negative 20, go.
A number.
Negative
Negative
17 and a half.
17 and a half.
Negative,
Negative 4,
Negative
14 and a half.
14 and a half.
Negative,
wait,
10,
guys, we have
negative 10,
negative
Negative
15,
10.
and then negative what?
oh, right. Negative 12 and a half.
Negative 12, yeah.
Nice,
Negative 12
keep
and a half.
going.
Negative 10.
Negative,
Negative
yeah,
10, come on, negative,
Negative 7
negative 7 and a half.
negative,
Negative
Negative 5.
negative,
Negative 2 and a half.
but don't ever say negative.
0.
2,
2,
4, 6,
6,
8. Who do we
we
appreciate?
appreciate?
Dilation, dilation, go,
Athletes.
dilation.
Athletes.
I will see you guys in 166 hours and 57 minutes. And I'm really excited to see your dilations and what they do. Remember, computers use this technology all the time. Every time you
So does
swipe
Google.
out and swipe in, swipe out and swipe in, you're dilating bigger than 1 and between 0 and 1. Have a wonderful, wonderful week.
Wait, You
Okay,
just did
guys.
you just did your ending with 2 people.
I know. I'll see ya. Cheers.
Cheers.